This video is a tutorial for tutorial 3A question 9. Question 9 tells us that the curve C has the equation x squared over 9 minus y plus 2 squared over 16 equals to 1. We recognize the form of this. Okay, so the first thing we need to do is draw a sketch of this curve C, clearly indicating the main relevant features of the curve. The first thing we recognize is that this is in the x squared minus y squared equals to 1 form, which means that we're dealing with a conical hyperbola which will look something like this. So we know that the main features are going to be the coordinates of our vertices, these 2 points here, our asymptotes, their equations, and any points of intersection with the axes. So if we look for axial intercepts, what do we get? Well, when x equals to 0, we get negative y plus 2 squared over 16 equals to 1. Y plus 2 squared equals to negative 16, and already we can see that this implies no solution. So therefore, no y-intercept. What about when y equals to 0? That gives us x squared over 9 minus 2 squared over 16 is equal to 1. That means that x squared is equal to 2 squared over 16 is a quarter, 3 quarters. Move that over, we get 5 quarters. So we get 1 over 9 x squared is equal to 5 over 4. Multiply both sides by 9, you get x squared is equal to 45 over 4. You get x is equal to plus minus 1/2. Square root 45 is 3 root 5. So that's plus or minus 3 over 2 root 5. So that's our axial intercepts. Our vertices, well, we know that the center is going to be at the point 0 because it's x minus 0, and then minus 2 because it's y plus 2. And we know that the vertices, we set this part equal to 0, and then we just look at the denominator of the x squared term. So that's going to be, means that the distance is going to be 3, so therefore our vertices are going to be minus 3, minus 2, and 3. Minus 2. So distance square root 9 away from it, the center. What about then our asymptotes? Sorry, new page. So again, we have x squared over 9 minus y plus 2 squared over 16 equals to 1. So for our asymptotes, we set this equation equal to 0. So x squared over 9 minus y plus 2 squared over 16 equals to 0. So y plus 2 squared is equal to 16 over 9 x squared. So y is equal to negative 2 plus or minus 4 over 3 x squared x. So therefore our asymptotes are y equals to 4 over 3 x minus 2 and y equals to negative 4 over 3x minus 2. So with all this information, we're able to go and draw our graph. Again, our GC can be very useful to us here. I'm going to make use of GeoGebra for this one and just key in the original equation. So it's x squared over 9 minus y plus 2 squared over 16 is equal to 1. Gives us this equation. May as well key in the coordinates of my vertices. So that was 3 minus 2 and minus 3 minus 2, equation of my center, which was 0, negative 2, and then if you recall the points of intersection, I had that at negative 3 times the square root of 5 divided by 2, 0, and 3 times the square root of 5 divided by 2, 0. So you can see I've got my calculations correct there. I also had my two asymptotes. Y is equal to 4x over 3 minus 2, and y equals to negative 4x over 3 minus 2. And you can see those asymptotes come out perfectly as well. So this is what my graph looks like. It's the curvy part. You of course should draw these asymptotes with dotted lines. Okay, what about the second part? So the second part of this requires us by drawing a sketch of the line y equals to negative 2, x minus 2, sorry, we need to somehow deduce the result for this inequality. Well, this is a little bit tricky to see at first, so I'm just going to show you guys how we can make sense of it. Okay, well first of all, remember I'm starting with the equation x squared over 9 minus y plus 2 squared over 16 equals to 1. What happens if I rearrange that equation to make y the subject? Okay, well I would get 16 over 9 x squared minus 1 is equal to y plus 2 squared. So I would get 16 y plus 2 squared is equal to, and I'm looking at my end result thinking about how to make it work. This is going to be sorry, I multiplied through by 16, so there should be minus 16 here. So this should be 16 over 9 x squared minus 1. X squared minus 9, sorry. So factorizing this left-hand side here and moving it to the right-hand side, I can then take the square root, so I get y plus 2 is equal to plus or minus 4 over 3 square root x squared minus 9. So y is equal to plus or minus 4 over 3 positive square root x squared minus 9 minus 2. Now if you look at the inequality that we need to solve the inequality 4 over 3 square root x squared minus 9 is less than x. Well, this doesn't seem to have any relationship to our equation y equals to x minus 2 or to this, but you see if we put a minus 2 on each end of this inequality, then this becomes something that we can sketch, because this one is just our curve C, and this is the curve that we just drew in. Now, one thing we have to be careful of, this is not quite C. You notice that there's a plus or minus here. Here we're only taking the positive branch, so y has to be a positive number. It has to be strictly bigger than 0, so we can only consider this in the range where y is strictly bigger than 0. So keeping that in mind, we go back to GeoGebra, we ignore everything where y is less than 0, and what do we see? So I'm just going to do some quick edits here, hold on. Okay, so resuming, we see this is what it looks like. Oops, sorry, where'd it go? Here we are. This is what we look like. I've just turned this line into a dotted line, and I meant to turn the other one into that too, so hold on, let me just object properties, style dotted, there we go. So my asymptotes are now, oh, don't do that, my asymptotes are now dotted, and I'm looking for this intersection, but I'm going to ignore everything where that I would be taking the negative square root. So that means I'm only going to be paying attention to stuff above the line y equals to negative 2. So I'm going to ignore this point of intersection, and what do I want? I actually want where this curve x minus 2 is bigger than my curve C. So where the line, sorry, x minus 2 is bigger than my curve C. So where does that happen? That happens from here. Well, it doesn't happen most of the time because my curve C gets bigger and bigger and becomes parallel but above. But in between here and here, I've got a chance. Now, I also want you guys to notice that when x equals to 3, this stops. I can't make any conclusion. Like, this line is not above the curve when there is no curve. So I can't draw any conclusion for between 0, x between 0 and 3. But from 3 all the way through to this point here, which is 4.54, my curve is below my line, and that's what this inequality here is asking me to find. So my answer is going to be, from the graph, I need my curve to be below my line. That means that 3 needs to be less than or equal to x, but it has to be strictly less than the point of intersection, which was 4.54. And that gives me my final answer. One thing to note, I may have misspoken earlier. At this part where I said we need this number to be positive, I wasn't quite accurate, sorry. We just need to make sure that we're only taking the positive square root. That means I only need this part to be positive. That's why I want it to be above this line, y equals to -2, because if this is positive, or at least non-negative, then this whole thing must be bigger than or equal to -2. So just to clarify, I think I may have misspoken earlier.